similar to yesterday, but I have to do that so that people won't be able to say, oh, you never said such and such. I'm trying to be overly repetitive for obvious reasons so I can catch everybody. Okay, so test tomorrow. We haven't had a test in a while. Okay, so again, about 9:01, 9:02 tomorrow morning, I will send the exam via Canvas announcements. I'll also project it like this. So at the beginning of class, 9:10-ish, anybody who doesn't want access to Canvas announcements, so you can't reach it for whatever. So it's a redundancy. I want to be able to make sure everybody gets it. So I'll project this, but I'll only leave it up for a few minutes, and that way I can watch the rest of you. Okay, and then what are you responsible for? You're responsible for all of this. There's a 70% homework rule. You must turn in at least 70% of the homework. You know, that's not that hard to do considering I do a great bundle, great percentage of them anyway. You can submit the homework early. I don't mind if you submit it early. Okay, so during the test, show your camera. You must show your camera. Mute yourselves. Don't unmute. If you have a question, send it through the chat. If you finish early, you can leave early. And then at 10 o'clock, our usual stopping time, I will stop. And then I'll say, test is over. You have 5 minutes then to get your cell phone and click, 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 click. Take all the pictures or scan. Scan is usually better. So if you can scan your answers, then scan them. Okay, so the test would technically be due at 10:05. Okay, and then you have until 10:30 a.m. to submit the homework. But again, if you want to submit the homework early, that's okay. And watch out for the homework. Sometimes the homework gets too much. You can't send it all in one file. I'm noticing some of you have had problems with that. So if you want to send it in several emails, that's fine. Or do, you can go like what, 4.2, then 4.3, 4.4. You can have a separate email for each one, although you probably don't have to. So however you want. All I would say is I've seen instances where students said, oh, I can't send the whole thing in one email. Then send it in a couple or whatever. But if you can fit it all, that's great. Okay. Don't have your format in something that I can't open. I've had situations where I can't open the file, so nothing fancy. PDF is best. I can definitely open any PDFs, but if you start doing some fancy stuff, sometimes I notice I can't open the files. So please keep that in mind. You can use your cheat sheet. So 1 8.5 by 11, both sides. You can write whatever you wish, including formulas, sample problems for the test. Okay? And test questions are just like this. I usually tend to give about 10 questions. So that would mean 1 question from every section and maybe a couple more here or there. Okay. Then time-wise, we only have 2 more tests after that. They both cover less material. Okay. So tentatively, test 5 is only 2 weeks after, on the 20th of November, but it only covers 3 sections. And that goes to a Veterans Day holiday next Wednesday. Then our last exam after Thanksgiving, near the end. Okay, in case you want to know if you haven't already figured it out from the schedule, our final exam is Monday, December the 14th, 8:10 to 10:40 a.m. Okay, so please notice it's 8:10, not 9:10. So you have to get up earlier for 8:10 to 10:40 for the final exam. And to study for the final exam, you would just study the old exams, essentially. That's basically that. Okay. And let's see, I think that's all I need to say. Yes, I'm being redundant, no question about it. Okay, so let me go straight to checking the chat for questions and so forth. Okay, so go ahead and start filling up the chat with your questions. Okay, so 4.2, 27, 4.8, 41, 4.4, 41, 4.2, 31, 37, 4.7, 11, 4.6, 11, and 27, and 13, 4.7, 37. Okay, so let me double check I got it. 4.2, 27, 4.8, 41, 4.4, 41, 4.2, 31, 37, 4.7, 11, 4.6, 11, 27, 13, 37. Okay. Yes, the final exam covers everything, and the best way to study for the final exam is just from the old exams. So that way you don't have to study everything. That's too hard. So I'll limit it to material from previous exams. Okay, so that will make things easier for the final exam. I'll talk more about the final exam when it gets closer to it, probably like after Thanksgiving or so. Okay, so I have a batch right now. If you want to still keep adding to the chat, that's fine, but I can't see it while I'm working. So the last I got was 4.737, but we'll see how it goes from there. Okay, and again, I really don't want to do any problems which were not assigned. So if you ask me a question that wasn't assigned, I am likely not to do it, I guess. All right. See, 4.741. Okay, I'll put that, and we'll see how it goes. Okay, so I will not be able to see the chat as I start sharing now. Okay, so we'll go right to it. Okay, yeah, have your calculator handy and be ready to switch back and forth between degree and radian mode. Okay, so the last section, law of sines, law of cosines, mostly is in degrees, but everything else quite often in radians. Okay, now there was a lot of stuff where you didn't need a calculator. Obviously, you can use your calculator to double check, but I need to see the analysis like we did in class. Okay, so maybe I'll just go by sections, see how much time we have. 4.2. 4.227. Okay. Okay. P of t has coordinates negative radical 5/3, two-thirds. Okay, that is in quadrant number 2. Okay. So what's the point at t plus pi? So t plus pi, that's 180 degrees off. So these are just reversed, right? It would be positive radical 5/3 and negative 2/3. P of negative t. Now let's see, negative t would land me here. Okay, so all that would be is third quadrant, so they're both negative. So this would be negative t, so negative, negative. P of t minus pi. Well, you go back 180 degrees, but that lands you the same place as if you add 180 degrees. So it's the same point as A. Radical 5/3, negative 2/3. And finally D, P of negative t minus pi. So that brings me 180 degrees off of this, and that lands me in the first quadrant. So both are positive. So radical 5/3, 2/3. Okay, so you're just adding 180 degrees or subtracting 180, or just look at the picture and go by symmetry after that. Okay, so that's 27, 31. Section 231. Circle of radius 3 inches and arc length of 6 inches as angle theta. Find the measure of the angle in degrees and radians. Okay. So I draw myself a circle. Radius is 3. Arc length is 6. Okay, so the formula is S is equal to R theta, as long as theta is in radians. So plug in 6 equals R is 3 theta. So theta is 2 radians. Okay, and then in degrees, take 2 radians multiplied by 180 degrees divided by pi radians. 360 divided by pi degrees. Okay, and what is that approximately? 114.59 degrees. Okay, that's 31. 37. The area of a sector of a circle. Area of a sector of a circle with angle 45 degrees is 2 square feet. Find the radius of the circle. Okay. So we go like that. And we have 45 degrees, which in radians is pi over 4. I need it to be in radians. And the area is 2 square feet. Okay, so formula area is 1/2 r squared theta. So 2 is equal to 1/2 r squared. Theta is pi over 4. Has to be in radians. I reach the bottom on the paper, but I'm going to make that as pi over 8. 1/2 of pi over 4, pi over 8. So 2 equals pi over 8 r squared. And multiply both sides by 8 over pi. 8 over pi. So that gives me 16 over pi equals r squared. Square root. R is equal to 4 over radical pi. And the units are feet. Okay, and squiggly equal 4 divided by square root pi, 2.26 roughly, 2.26 feet. Okay, so that's it for 4.2. 4.441. 4.441. Sine of t equals -1/2. Find all values from 0 to 2 pi that satisfy. Okay, so we're going from 0 to 2 pi. Okay, sine of t means you want the y coordinate. Y coordinate is -1/2, so I go halfway down here. Go like that and like that. Okay, so that looks like it's 30 degrees. That looks like it's 30 degrees. So I have to switch over in radians. That's 11 pi over 6. That's 7 pi over 6 from experience. Okay, so I know that's pi. Add 30 degrees. 210 degrees total. 7 pi over 6. 11 pi over 6. So t is 7 pi over 6 and 11 pi over 6. Okay, so that's what I would do for that one. So that's 4.441. 4.6. 4.6. 11, 13, 27. Okay. See. And I know I might be going fast, but on days like this, I'm going for what? Quantity more than quality. I want to make sure I get it all down. You can always review the video later and fast forward, rewind as much as you need. 4.611. Find the values of all the trig functions given the information. Okay. So cosine t is equal to -4/5. T is between pi and 3 pi over 2. Okay, so that means I'm in quadrant 3. Okay, sine squared t plus cosine squared t is equal to 1. Sine squared plus cosine is -4/5 squared equals 1. That comes out to be 16 over 25. plus 16 over 25 equals 1. Subtract 16 over 25. 1 minus 16 over 25 is 9 over 25. Square root, square root. I'm in the third quadrant, so the sign of the sign is negative. Negative 3/5. And once I have that, and I have that, then everything is just ratios and reciprocals. Okay, so I got the cosine and the sine. Let me summarize back up here. So I'm going to go up top. Draw myself a little arrow there. So I have sine of t was negative 3/5. Cosine t was what? Negative 4/5. Okay, so tangent is sine over cosine. Negatives cancel, the 5s cancel, 3/4. And then just what's the reciprocal of what? Remember, my memory trick is if one function has a co, the reciprocal does not have a co. Sine, no co, so therefore cosecant. Cosine, co, so reciprocal does not have a cosecant. And most people don't have any trouble with tangent, cotangent. Okay, so flip, flip, and flip. Okay, so that's it for 4.611. 13, same section. Tangent of t is equal to 2. 0, okay, it's in quadrant 1. Quadrant 1. So everything's positive. Okay, I think the best way to do this is 1 plus tangent squared is equal to secant squared. Use that identity. 1 plus 2 squared is secant squared. 1 plus 4 is 5. 5 equals secant squared of t. Square root, square root. So secant t is radical 5. And then flip, reciprocate. Cosine t is 1 over radical 5. Then sine squared t plus cosine squared t equals 1. Sine squared t plus 1 over radical 5 squared equals 1. Comes out to be 1/5. Okay, 1 minus 1/5 is 4/5. Take the square root. Square root. Sine t is equal to square root of 4 is 2 over radical 5. That looks very similar. I think we had a quiz question that was very much like that. And if you don't mind to save time, I think you got the rest of it. Once you have that and that, you can get the rest. So if you don't mind, I'll abandon the problem. In fact, well, they already gave me tangent. So now after that, just flip, 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 flip. Okay, so I'm abandoning 13, if you don't mind. The rest is just like this. Okay, once you have the sine and cosine, you got the other 4, right? Sine divided by cosine is tangent. Just do the same thing as this, and then flip, flip, flip. Okay, so if you don't mind, I'll abandon that problem. I think you're good from there. Okay, 4.627. 4.627. Let's see. Y equals tangent 2x minus pi over 2. Okay, I will factor out the 2. X minus pi over 4. Okay, so the period is pi divided by b. This is the b. Okay, so the period of the tangent function is pi, also for cotangent. For all the others, it's 2 pi. Period of the sine, cosine, secant, and cosecant are 2 pi. Okay, in which case you use the formula 2 pi over b. But for tangent, it's just pi over b. You can go ahead and put that on your cheat sheet if you wish. So in this case, period is pi over 2. Okay. So the way the tangent goes is it straddles 0. So that means 1 period I can get from negative pi over 4 to positive pi over 4. Negative pi over 4, pi over 4, asymptote, origin, quarter mark, 3/4 mark. Okay, increasing, so -1, 0, 1. Okay, so this is tangent to x, and now tangent of 2 times x minus pi over 4. I just shift this whole thing pi over 4 to the left. So this becomes here. This goes over to there. My asymptote is going to be the y-axis, negative pi over 4. Move pi over 4 to the left, that's negative 2 pi over 4, which is negative pi over 2. Okay, so now I try to draw the same shape, but it's moved over pi over 4 to the left. So that's my 0. There's 1. There's negative 1. Okay, so that is tan 2 parentheses x minus pi over 4. Okay, so that is 7. Whoops. All right, so let's see, that's it for 4.6. 4.7, I have a few, 11. 4.7, 11. Sine of 13 pi over 12. Okay, so I it says use either a double or half angle formula. So if I take half of this, I have 13 pi over 24. I don't really recognize that. But I can deal with 13 pi over 12 times 2, which is 13 pi over 6. Okay, because that is 12 pi over 6 plus pi over 6. That's 2 pi. So it's going all the way around the circle once, plus another pi over 6. Okay, the other thing I want to note is that this original angle is in quadrant 3. So let me draw myself my unit circle. Okay, where is 13 pi over 12? Well, this is pi, which is 12 pi over 12. So 13 pi over 12 is a little bit bigger. So it's quadrant 3. So that means the answer is going to be negative. The sign of the sign, S-I-G-N of the S-I-N-E, is going to be negative in quadrant 3. So I know my answer is going to be negative. Okay, and then if I double the angle, 13 pi over 6, that's going all the way around and then another 30 degrees. So here's 13 pi over 6. Okay, it's 2 pi, 12 pi over 6, plus another pi over 6. Okay, either x or y is a half. So I go like that, I go like that. The x looks like it's way more than half. The y looks like it's a half. So 1/2 is always squared with radical 3 over 2. All right, so I'm going to use the formula sine squared of theta equals 1 minus cosine 2 theta over 2. Okay, so smaller angle, double the angle. So smaller angle, I double the angle, is 13 pi over 6. So 13 pi over 12 goes here, 13 pi over 6 goes here. So sine squared of 13 pi over 12 equals 1 minus cosine 13 pi over 6 all over 2. Okay, cosine of 13 pi over 6, radical 3 over 2. If that's sine squared, I just want sine, so I do the square root, and I already know that I have a negative because I'm in quadrant 3. So I have what I want, sine of 13 pi over 12 is negative this stuff. We don't usually like to leave it like this. So multiply top and bottom here by 2 to make it look nicer. That way the bottom is the square root of 4. Square root of 4 is regular 2. This becomes square root of 2 times 1 is 2 minus radical 3. So that's the best final answer. Yes, I have a square root inside a square root, kind of clumsy, but that's the best that we can do under the circumstances. Okay, 4.737. Verify the identities, okay? So 37 secant x is equal to, oh no, secant x minus cosine x, sorry. Secant x minus cosine x is equal to sin x tan x. Okay, verify the identity. Okay, draw my barrier. So I can't cross until they match. All right, I'd like to change everything to sine and cosine. So secant is 1 over cosine minus cosine x. And what do I get a common denominator? Cosine x, cosine x, 1 minus cosine squared x over cosine x. 1 minus cosine squared is equal to sine squared. And that's about all I need to do there, and that doesn't look too hard, because now on this side, tangent is sine over cosine, and that gives it to me right away. Sine squared x over cosine x. Oh, they're equal. So it matches. Okay, so that was 37, and now 41 was asked for. Find all values of x in interval, blah, 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 blah. Okay, so 41, 2 sine squared x. And this is the way it's normally written. The book writes it like this. Sine x squared. And that is how you would type it in on some calculators, but the normal way to write it is like this. 2 sine squared x. Got to write the rest of it down. Plus cosine x minus 1. Okay, so factor. It's a quadratic equation. Oh no, I take it back. I can't factor yet because these are different. Not bad. I got to change it to cosine. So sine squared is 1 minus cosine squared, right? I have to get everything to just one trig function here. So 2 times sine squared, which is 1 minus cosine squared x, plus cosine x minus 1 equals 0. Check sure that I wrote that correctly. Yeah. Okay, so remember I'm piggybacking off this identity sidebar here. Sine squared theta, cosine squared theta is 1. So if I subtract cosine squared, I get sine squared equals 1 minus cosine squared. And likewise, cosine squared is 1 minus sine squared. So that's what I'm doing here. So that is only one trig function. Okay, so let's clean this up. 2 minus 2 cosine squared x plus cosine x minus 1 equals 0. And let's see, 2 minus 1 is 1, right? So negative 2 cosine squared x plus cosine x plus 1 equals 0. Okay, and normally I want the leading coefficient positive, so we'll multiply both sides by negative 1 just to make it look nicer. 2 cosine squared x minus cosine x minus 1 equals 0. Okay, now I'm ready to factor through this stuff. 2 cosine x, cosine x. How do you get 1? Well, 1 and 1. 2, and then with a negative, the negative should go here. it, right? Double check by FOIL, multiply back out, 2 cosine squared minus 2 cosine plus 1 cosine. Yeah, it works. Okay, so either this is 0 or this is 0. 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. A little bit of algebra. Cosine x is negative a half, or cosine x equals 1. Okay, so draw my unit circle. Okay, we're supposed to have something between 0 and 2 pi, right? Inclusive. Okay. X coordinate is 1 here. X coordinate is negative a half, so I go halfway across there, and go there, and go there. So that looks like 120 degrees, 2 pi over 3. That's 240 degrees, 4 pi over 3, and that's 0 and 2 pi. Okay, so it looks like I have 4 solutions: 0, 2 pi over 3, 4 pi over 3, and 6 pi over 3, 2 pi. Another way to think of it is go every 120 degrees. Start at 0, 120, 120, 120, and then you got it. Okay, then let's see, that's that, 4.841, then I'm done with that batch. 4.841. Okay, so we did that yesterday, I think. Similar themes. Tangent of arc sine of x. And they give you the answer, but pretend they don't give you the answer. This is like the back of the book. I'll derive that answer. And yeah, never mind about all this other stuff. It's just to make everything quote unquote nice, and you don't have to worry about plus or minuses. So don't worry about that. So the procedure is normally call that theta. So find tangent theta. I'll have to do my SOHCAHTOA, right? You say, what's SOHCAHTOA? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You're welcome to put that on your cheat sheet. Okay, so theta is arc sine x. Rewrite it without the arc. So is it sine x or sine theta? No, it can't be sine x because it's arc sine x. So it must be sine theta equals x, which I'm going to choose to write as x over 1. Okay, draw my right triangle. Theta sine is opposite over hypotenuse, x1. Do your a squared plus b squared equals c squared. That came out to be 1 minus x squared. I think I did it yesterday. So you can check, or just do your Pythagorean theorem. It was radical 1 minus x squared. Okay, then we were trying to find tangent. Tangent is opposite over adjacent. So x over radical 1. And that is that. Okay. And let's see. Yeah, I think I've caught up with that batch. Right, so I will stop the share and check the chat. Okay, how far did I get up to again? Sorry, wait for me to get organized here. Okay, 4.737, I got that. 4.741, I did that. Okay. How many questions on the final exam? Oh, I don't know. I usually give 10 on regular tests, so what seems reasonable? 15, 20, maybe? That's just a guess right now. Okay, 4.625. Okay, 4.625 and 4.825. That's all I see right now for this round. Anybody want to type something in quickly before I go over? Are we allowed to use previous cheat sheets in the final? Yes. In fact, that's what I want you to use. Just take the cheat sheets from the first test, second test, third test. Don't reinvent the wheel. You already got it, so just have them all ready for the final exam. So all the cheat sheets from before, just use them all for the final. Okay, good deal? Okay, I think that's it. So 4.625, 4.825. So let me try that. What time is it? 9:47-ish. Okay. So I'll go back to sharing the screen. Okay, 4.625, please. Let's see. 4.625. Graph y equals tangent pi over 2x. I'm going to write it like that so that this is the b. The period is pi over b, pi over pi over 2. If you divide by pi over 2, you multiply by 2 over pi, which is 2. And that's nice. Okay. The period is 2. It straddles 0, so that means I go 1 unit this way, 1 unit this way, -1, 1. But everything else is the same. It goes like that, like that. So that would be -1/2, 3/2, 0, 1, -1. It's increasing. So something like that. So it has the same general shape. All that's happening is I'm either stretching it or compressing it or elongating it. Okay, so that's that. And then 4.825. 4.825. Arctan tangent pi over 3. Yeah, at first glance, you might just want to say, oh yeah, arctan and tan cancel out. That's actually true here, but you want to be safe. It's going to be true as long as you have an angle between -pi over 2 and pi over 2, which is where the tangent or arctangent goes from, and that angle's in there. But let's just work it out to be safe. So pi over 3 is 60 degrees. It's right there. What is this ordered pair? So either x or y is halfway across. Y looks like it's way more than half. X seems more like a half, so this is 1/2 radical 3 over 2. So tangent pi over 3 is sine over cosine. Basically, it's the y over the x. So radical 3 over 2 divided by 1/2, which is radical 3. So this is radical 3. And now I want arctan of radical 3. So what angle is there between -pi over 2 and pi over 2, which gives me the tangent of radical 3? Well, we just did it. It's 60 degrees for pi over 3. So yes, in this particular case, they do quote unquote cancel out. Okay, and I think I have time. What if you were just given that and we didn't do this? So let me show you that trick again. If it just says, how do you find arctan radical 3? So let me go through that. How do you come back with a pi over 3? So suppose it just says arctan of radical 3. So first I would call it theta. Write it without the arc. I'm taking the tangent of something. Am I taking tangent of that? No, I'm taking arctan, so it must be tangent theta is radical 3. Sine over cosine, radical 3 over 1. And you remember that trick I did? Excuse me. You divide top and bottom by something. Remember what that something was? 2. Right? Then you just equate these. sine of theta is radical 3 over 2, and cosine of theta is a half. Certainly more comfortable with a half than radical 3 over 2. So I say to myself, I want the x-coordinate to be a half. So it looks like that's over there. Okay. So this was 1/2 radical 3 over 2. Then I just say to myself, what angle does that look like? Looks to me like it's 60 degrees. Pi over 3. Like that. Okay. Let's see. Yeah, I think I'm caught up with that round. So we only have about 5 minutes left. Okay. So I think I've caught up, but it's very easy for me to miss something. So if I missed your question, you can ask it now, please. Otherwise, we're just about done. Okay. Anything else, please? Otherwise, we're done for the day. Okay. I don't see anything or hear anything, so we're done. All right. Yeah, you can submit your homework early, even now if you wish, although I normally prefer it to be on Friday, but if you want to submit it now, that's okay. All right. So around 9:01 tomorrow morning, I'll send over the exam on Canvas announcements, but I'll also project it, and you know all the rules there. Okay. All right. So bye, everybody. We'll see you tomorrow for the test. Okay. All right. Bye.